The other interesting thing, the last thing that I would like to show you is something that we have developed, which for us is equally exciting, and we'll be testing it very shortly at Goa on the ramp that is being built there. What is known as the automatic ramp takeoff. Now, for a naval aircraft, normally an aircraft which is operating from this thing like a runway, you have typically for this class of aircraft anywhere between 600 to 800 meters of length available to build up speed, build up lift, and take off. But in the case of a ship, you have only two choices. Either you use a catapult to accelerate the aircraft to that speed to generate the adequate amount of lift to support the weight, or what many other countries like Russia do is they have a ramp on the thing, and then what happens is as you travel on the ramp, you release the aircraft in a semi-ballistic trajectory, and then ultimately it becomes wing-borne. And this one just shows the vector diagram of the various stages of this type of takeoff. And the length that you have will be typically from about 160 to 200 meters. And you need to take off the same aircraft from this deck in that shorter length. And that again is an extremely challenging thing because there are restrictions to that. One is, as I said, shortage of runway length, and it's also a very strong function of various other parameters like the mass and inertia of the aircraft. And there are also additional requirements. In order not to disorient the pilot, we also have to ensure that the flight path angle after it leaves the ramp is always positive. That means at no instant of time is the aircraft coming down like what's shown on the top. And it also puts a constraint on the minimum angle of attack, maximum angle of attack, because beyond that angle of attack you could land up into a problem. And this is typically just tells you the conditions of such a takeoff. And what is interesting is for people who are flyers or have know something about flying, you can see that this type of ramp takeoff, you see how fast the flight path angle changes, how fast the theta build-up occurs, and you can have G's of the order of 2.5 to 3 G when you exit the ramp, and you can see the sort of pitch rate, that is the rate at which the nose oscillates itself, can be very distinct. So it is quite disorienting, and it needs a lot of training for pilots to take this aircraft from the deck of a ship. So what we have contemplated to do for the naval aircraft is to build in an automatic hands-free takeoff mode, wherein the pilot has just to ensure the center line tracking with the pedals, but the aircraft will take off automatically, and the control will be given back to the pilot once he achieves wing-borne flight. So this would help getting the aircraft into the system much earlier with lesser amount of training. So this again is a very challenging task for a tailless delta wing aircraft. And this typically shows again what would happen if I did not have this ramp and I used a conventional control system. So I thought